Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this minimum sum partition problem of GFG. So let's move on to the problem, guys. So here we are given an array ARR, name as ARR of size n with n non-negative integers, and we have to divide it into two sets S1 and S2 so that the difference between sums is minimum. Like suppose if this is the array, or this array contain element a, b, c, d, e, then we have to divide all element in two sets. Okay, all elements should be covered by two set and each element should belong to only single set. Suppose a, b belong a, d belong to this, b, c, e belongs to this. So the difference between sum of a plus d and b plus c minus e should be minimum. Okay, so we have to divide the array element in such a way so that the difference between the sums of both sets is minimum. Like here we can see this is a set given to us 1, 6, 11, 5. So we can divide 1, 5, 6 in one subset and 11 in one, so that minimum will be sum of element of subset 1 is equal to 12 and other one is 11. So differences of 1, like here 1 and 4, we have to divide 1 in one set, 4 is in another set. Okay, so here difference is equal to 3. So guys, we have to do this. Now how we will do it? So in other word, what I can say, this is array given to me. Now I have to divide it in subset S1 and in subset S2. Okay guys, now one thing I know, S1 plus S2 means the sum of element in S1 and S2 will be is equal to my sum of array element, sum of all element, because all elements should be covered by S1 and S2. Okay guys, so what if I say you, if I know sum, because I have array, I can calculate the sum. Like here I'm calculate the sum of all element in my vi, in my array v. I renamed it as v instead of arr. So what I can say, if I found any one subset sum, if I found like this is my sum and this is my S1, then I can easily found S2. I can easily found S2. How? S2 will is equal to sum minus S1. Sum minus S1 means sum total sum minus sum of element cover in my S1. Okay, or the remaining element will cover by my subset 2. Okay guys, so how can I check it for the minimum one? Like we have to find out the minimum. So what we can do, using dynamic programming, using DP, I will find all the subset S1. I will found all the subset S1 that I can make using the element of my array V. Okay, now if I found all the subset, I know these are the possible subset. Like suppose 1, okay, take some simple example, 1, 2, 3 and 4. Suppose these 4 are the element given to me. So or 1, 2, 4, take this example. Now guys, I know total sum is just thick marker. Okay, total sum will be 4, 5, 6, 7. So guys, how we will find out how many different subset I can make? So what I will use dynamic programming. How? I will make a DP table or DP array of size is equal to 7 plus 1. Why 7 plus 1? Because the maximum sum I can make is still 7. 0, 1, 2, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 5, 6 and 7. Initially all will be 0. Initially all will be 0. 0 means okay, so what is DPI means? DPI means, so what is DPI means? DPI means, can I make some I? Some I. Can I make element of some I? Like here 0 means, can I make some 0? Okay, 1 means DP1 means, DP1 will always be either 0 or either 1. It is a boolean. Okay, I make it, take it of int I, but it is boolean 0 or 1. 0 means I cannot make a subset of sum is equal to I. 1 means I can make a subset of sum is equal to I. DP1 means yes, I can make a subset using this element, any number of element of any number of element. Okay, I don't care about number of element because the sum is constant. sum minus s1 is will always gives me s2. Okay, because the sum will always remain constant. S1 plus s2 will always is equal to sum. Now dp2 means, can I make subset of sum is equal to subset whose sum will be 2? Can I make subset whose sum is equal to 3, whose sum 4, 5, 6, 7? Similarly, now one condition I know, I always able to make dp0 as well. I will not select any element. I will not select any element, so I can make dp0 is equal to true always, because my sum is equal to 0 means my set is empty. I don't select any element in this particular set. Okay guys, now for each element 1 to 4 I will traverse this dp table again and again. Okay, this dp table again and again. This is just like an abstract problem. Oh sorry, subset problem, some subset problem. So okay guys, so how I will traverse? I will traverse using 1, and I will start traverse from back, from behind, from 7. Why not from 1? Suppose if I start from 1, then I can make 1. I can make 1 like how I will guarantee I can make 1? Or suppose my current element is x and I have to form some I, then what is the guarantee I can form I? Like suppose my I is equal to 5, my x is equal to 1, and my I is equal to 5, means I have to make 5. I have to make 5 with using current element 1. So how it will guarantee me that I can make 5? I can only make 5 if I can make 4. How I can make 4? I will gonna to add 1 in it, so it will gives me 5. Okay, so I can only make a sum is equal to I when I minus x sum I can make, means 5 minus 1 I can make, then I can make I as well, because already sum I can make. I will add this element, so I can make 5. Okay guys, so now here for 1, can I make 1 minus 1, that is 0? Yes, here 1 will come. Now can I make 2? 2 minus 1, 1 I will make, I will make 1. Okay, so using only 1 I cannot make 2, but it is given me I can make 2. It is given me I can make 2. Why? Because first of all, I first suppose this 3 is my dp table. Suppose for a minute, this is my dp table with index 0, 1 and 2. This is 1, these both are 0. I change it to 1 because I can make 0. Now I have to change it to 1 because I can make 1, but this is not the case. I have to start from back. How I can make 2? I cannot make 1, so I cannot make 2. I can make 1. Yes, I can make 1 because I can make 0. So after doing reverse iteration, I can see I can only make 1. That is the true condition also, because I cannot make 2 using a single element 1. I never able to make 2. So I will start iterate in my reverse order. Okay guys, this is the case. I hope you all understand what I want to say. If not, then just try run. As well, you can comment out. I will explain there, because like for 7 you have to check if you can make 6, then you can make 7. But if you can suppose you have you can make 6 using this one, you are making 6 using this one, then for 7 again you are using this one. Okay, like here you are making 2 when you are doing from 0, you are making 2, choosing using, because you can make one sum 1, but you are making sum is equal to 1 using this one element, okay, so this is not fair, because I can use this one only once. So either I can make 1 from it, or either I can make 2, but it is not possible that first of all I use it to make 0 to 1, then I am again use it to make 1 to 2. Okay, this is not a fair case, so I have to use from back. So for 7 I can make 6. Okay, so these 3 I am taken 1. I can make 7. I can I make 6? No, I cannot make 6. 5, 4, 3, 2. Now can I make 1? Yes, I can make. Why? Because I can make 1 minus 1. 1 I, this is my I, this is my x. I can make I minus x. 1 minus 1, 0. So I can also make 1. Or I will change it. Okay guys, so now I have completed 1. So from 1 I can make only some 0 or 1. You can say if I take it, then I can make some 1. If I don't take it, I can make some only 0. So now I am taken 2. Can I make 7? Can I make 7 minus 2? 5? No. So I cannot make 7. I cannot make 6 because I cannot make 5. 4? No. Can I make 4? No. Can I make 3? Yes, I can make 3. Why? Because I can make 3 I minus x. That is 3 minus 2. That is 1. I can make 1. So I can make 1. So I can make 3 as well. I can make 3 as well. Now Can I make 2? I can make I minus x, that is I can make 2 minus 2, that is 0. I can make 0, so I can make 2 as well. So sorry, so here it will come 1. Okay guys, so in next, so after using 1 and 2 element, you can make 0. You don't select any element, select only 1, select only 2, select 1 and 2 both. Okay, so now for 4, so I know now you are taking 4. Now from 4, can you make 7? 7 minus 4 is 3. Can you make 3? Okay, so you can make 4 7 as well. You can make 7 as well. It look like cancel 1 and 1 both look same, so I have to erase. So I can I make 6? 6 minus 4 is equal to 2. I can make 2, so I can make 6 as well. Can I make 5? Can I make 5? 5 minus 4 is equal to, I can make 1, so I can make 5 as well. I can make 5 as well. Can I make 4? I can make 0, so I can make 4 as well. So here you can see all the subset from 0 to 7 I can make. Okay, I can make. So how I will check it? Either you can start from here or check for each minimum difference, or what you can do, you know the sum is equal to 7, so we'll find the mid sum. You will find the mid sum. What is the mid sum? Sum divided by 2, like suppose as it is sum divided by 2, that is 7 divided by 2 is equal to 3 plus modulo 1, 7 modulo 2 plus 1, that is 4. So you will start to check from index 4, because you know if you can make this, if you can make like if you can make this, then you can also make 5. Why? Because sorry, just a minute. So you will start from 4, so you will check on behind this, because you know if you can make some part of it, like you can make 3, then you can also make some minus 3, that is you can also make 4. You can, if you can make 2, then you can make 7 minus 2, that is you can also make 5. Why it is? Because these 2 represent single set, so this 7 represent complete element. 7 minus 2 is equal to 5. So it means one set contains sum is equal to 2, so other set sum will be is equal to 5. Okay, so if one set contain 2, so the remaining element whose sum will be is equal to 5 will be, this is 5, whose sum will be is equal to 5 will be in other set. So and this DP table will gives us the all possible subset sum, so 5 will always be true, means I can make 5 as well. Okay guys, so this is what I can make use, and whose subset sum I will found. Like here I can make found 4, it means I can make 4. So 4, like I am explaining to you. This is 0, means no element select. This is a sum, means all elements select. I am start checking from here, that is S is sum divided by 2 plus sum modulo 2, the mid value. If I can make this, it means there is one subset whose sum will be is equal to S, because I can make this. So other subset S2 will be is equal to sum minus S, because sum S1 plus S2 will always be, or you can say it is equal to S2 is equal to sum minus S1. So sum minus S, because subset 1 sum will be is equal to S, because you can make subset of sum is equal to S. So you can see if you can make S, you can make sum minus S. So this will gives you the minimum answer. Okay guys, and if you cannot, like suppose here is a case where you can only make, like suppose you can make sum 1, or suppose there is a DP table. Zero, 1, 2, 3, 4, 5. Suppose 5 divided by 2 plus starting from 3. Suppose this is 1, 0, or suppose this is 0, 0, 1, 0, 1, 1. Suppose this is the case. This is the case when you have only 1 and 4. You can make 1, you can make 4, you can select both, and 1, 0 will be always 2. So we will start from 3. So you can see you cannot make a subset whose sum will be equal to 3. You will decrease S2 by 1. You can increase it or you can decrease it, because S1 plus S2 will always remain sum. So I am decreasing it toward 0. Okay, so here you will check S2, I cannot make it. So S will be became 2, I cannot make it. S will become 1, yes, I can make a subset of 1. So this 1 means subset 1 sum will be is equal to 1. So subset 2 sum will be is equal to total sum, that is 5, minus sum of this subset, that is 1, that is 4. So the minimum difference is 4 minus 1, that is 3. Okay guys, this is what I want to say. Okay, I hope you understand the approach. This is a DB problem. I found a single subset. I found the other subset by decreasing its sum from total sum. Then this is the minimum. And now you can argue with me, like why we select 1, why not 0? Suppose select 0 now. Instead of 1, we can take 0 as well. Take 0 now. S1 is equal to 0. So S2 will be became sum minus S1, that is 0. So sum will become 5. So difference is 5 minus 0, that is 5. So here difference is 5, here difference is 3. So 3 is minimum. So you will take minimum. And one more reason, suppose here you will take 1. Suppose here you have suppose any other case where you can take subset 2, 1 is equal to 10, sum of subset 1, and total sum suppose 20. So sum of subset 2 is 20 minus subset 1 sum, that is 10. So sum of element of subset 2 is equal to 10. So difference is 0. Okay, in this case S1 is equal to S2 0. Now you can suppose you can make 9, 8 and all other subset as well. Suppose for a minute all other make, then it means you are taken 9, you are decreasing its value, you are adding some minus here, you are doing some minus here. So minus minus plus, so you are increasing. So it means you are increasing S1, decreasing S2, so the difference is increasing. Okay, so the difference will increase. You are doing S2 minus S1, and you are decreasing its value, increasing its value, so the gap will become bigger and bigger. So the minimum value will always be found when first one means first subset whose sum can be possible to make is found. Okay guys, so this is the approach here. I hope you understand. I try my best. So here you will take dp of sum plus 1, you will initialize it with 0. dp 0 is equal to 1 means you can make 0 sum always for each element for sum to greater than vi. Why vi? From 2, like if your current element is 2, then you can only make 2, 3, 4 any other element. You never be able to make 1 or 0 from 2, because 2 is the at least sum that you can make. So that's why till vi only run. So dpj I am using or means if dpj is already set, then it will remain set. Else while if my dpj minus vi is set, means I minus x. Here j is I, vi is x. So if I minus x means j minus vi is set, dpj will set. Means dpj is set, it will remain set. Set means it will become 1. Set means 1. Okay. So and after all I will take SS sum divided by 2 and sum modulo 2 for odd cases. Like here you can see my answer is lie between 3 and 4. Okay, you cannot take it or you can take it, it's completely up to you. So while my dps is equal to 0 and note means is equal to 0, you can also write is equal to 0 means I cannot make subset, I will decrease it, because I know at s is equal to 0, this loop will gonna to stop because my dp0 is already 1, I set it. So and I will return absolute of subset 1 sum is s, second subset sum is sum minus s. So I will return the difference between these two. So this is what I am doing. What happens? Okay, meanwhile this is a hard problem, but I try my best to explain you in simple dp way. Okay, this is a tabulation dp. You will find it very easy once you dry run it on using pen and paper. So I hope you will understand the problem. If you have any doubt, then just comment out. I will try my best to explain you. Please subscribe the channel, like the video, and check out my channel for more this type of videos. I upload the GFG problem of that solution regularly. So be subscribe my channel, and thank you for watching this guys. Stay tuned.